Today's topic is error analysis. After finishing the dimensional analysis, now this is the part of the first unit, that is measurement system unit of unit and measurement chapter, and error analysis is the part. Now, what do you mean by measurement of a physical quantity? The measuring process is essentially the comparison, a process of comparison. Suppose you are going to measure the length of a rod and the length is say 5 meter. So it's nothing, but if you place a 1 meter rod scale 5 times, say 1 meter, then again 1 meter, then again 1 meter, then again 1 meter. So it's nothing but 5 times of 1 meter, 5 times of 1 meter. So you are doing nothing but comparison. So measuring process is essentially a process of comparison. You are comparing this length of the rod with a 1 meter long meter scale, and then the final measurement may come to be 5 meter. So it is 5 times of 1 meter. Now what is the error? Error, the word itself is the difference between true value and the measured value of a quantity, physical quantity, is called error. True value and measured value. Suppose true value of the length of this pen is 10 centimeter, and if you are measuring it by some instrument and it comes to be 9.8 centimeter, it means 0.2 centimeter is the error. If the true value is 10 centimeter and your measurement comes to be 9.8 centimeter, means 0.2 centimeter is the error. So it is nothing but difference between true value and the measured value. Measured value. Am I clear to you? So what is error? And then error in a quantity is nothing but true value minus measured value. Up to this portion, all of you have written? Written? Okay. Try to write the definition first. And then we are moving towards types of error. Types of error. Types of error. Now basically there are 3 types of error. The first one is systematic error. Systematic error. The second one is random error. Random error. And the third one is gross error. Gross error. Now systematic error, random error, gross error. We will discuss one by one. What is systematic error, what is random error, and what is gross error. So we are discussing first systematic error. So systematic errors are errors which occur according to a definite pattern. So systematic errors are the errors which occurs in a definite, which occur according to a definite, according to a definite pattern, according to a definite pattern. You might have seen screw gauge, vernier caliper, maybe voltmeter, maybe ammeter. It has some error, 0 error, something like this. And this error is systematic. If you know already that this particular device is having some error, then you can, if the error reason is known to you, then you can finally remove that portion of error also. So this is called systematic. Now the cause of systematic error are known. The cause of systematic error are known. So remedy is also there. If the cause is known to you, then one can minimize it, and therefore such errors can be minimized, and therefore such errors can be minimized. Now the second one, if you see the types of systematic error, then systematic error is further divided. Now types of systematic error. Now the first part is, suppose I am writing 1, 2, 3, 4. So first is instrumental error. Instrumental. Instrumental error. The second one is, now what is instrumental error? You might have heard about zero error, okay, backless error. So these are the error due to imperfect designing of the instrument. That is manufacturing defect. So while manufacturing the instrument, there may be some error occur in the instrument. That error is nothing but instrumental error, like calibration. At the time of calibration of the scale of the instrument, error may occur. If you might have seen 1 meter long rod, measuring rod, and if the gap between 0 to 1, 1 to 2, 2 to 3 centimeter is not same, then the scale itself is defective. So why this error arises? Because of faulty calibration. Faulty calibration. So calibration, if you see the meter scale, 0 to 1 centimeter has 10 divisions. Okay, 0 to 1 has 10 divisions, but 1 to 2 may not have 10 divisions. It may have 8 division. Again 2 to 3 has 10 division. Then 3 to 4 may have 7 divisions. So if this type of error occurs, this is called instrumental error, and it arises due to faulty construction, faulty calibration, faulty way of manufacturing the instrument. This is called instrumental error. So let us write what is instrumental, which arise from the errors due to imperfect design. So this arise which arise due to imperfect design or manufacture or calibration. So this is the reason of instrumental error. And calibration of the measuring instrument, calibration of the measuring instrument, Okay, so this is the part of systematic error. Systematic error is further divided into 5 parts. So one of the part is instrumental error, because of faulty construction of the instrument, faulty calibration of the instrument, because of faulty manufacture of the instrument, this error arises. Now the second type of error, should I rub this upper part? Take the snapshot, taken, snapshot taken. Okay, now the upper part is the second part is, okay, that is imperfection in experimental technique. Imperfection in experimental technique. So if you don't know the correct way to perform the experiment, then also error will automatically be occur. Suppose you are going to measure the temperature of a person. So if you place the thermometer uh, below your armpit, now where it should be placed? It should be for a accurate temperature. You should place it inside the mouth of the patient. But if you place it below the armpit, then the temperature reading of your body temperature may not be correct. So why it happens? Because you don't know the correct experimental technique. What is the actual way of measuring the temperature of human body? And that's why it occurs. If you go to the doctor will press the thermometer in your mouth, and then he or she, the doctor will read the temperature from the thermometer by placing it inside your mouth. So instead of you placing the thermometer inside your armpit, they will they will place it inside your mouth to measure the correct temperature. So why it happens? Because you don't know the experimental technique. Suppose you are doing the experiment of Ohm's law, and in Ohm's law, ammeter should be connected always in series and voltmeter should always be connected in parallel. But you are doing just opposite. You are connecting voltmeter in series and ammeter in parallel. Then also you don't know how to how to perform this experiment. So then also the error will automatically be in the picture. So that's why imperfection in experimental technique. You may not know the how to take the reading because you don't know the list count of the apparatus and how to read the particular reading of this experiment or the apparatus. So this type of error arises due to imperfection in experimental technique. The third one is personal error. Personal error. So personal error arises due to your personal defect. Maybe one-eyed man has some difficulty. One-eyed man cannot find the exact center of the circle. It is difficult for him to locate the center of the circle. But if the person is having two eyes, then it is easy for him to find the center of the circle. So that's why this is personal defect. Now the fourth part is errors due to external causes. Errors due to external causes. Suppose you are performing some experiment where temperature should remain constant, but due to sudden change in atmospheric temperature, pressure of the environment, atmosphere, that change in pressure and temperature is going on. So then obviously the reading may not be correct. While performing the Ohm's law, it is advised that you should plug the key for a few seconds, maybe 30 seconds, maybe 20 seconds, and within that time you have to note the reading of ammeter and voltmeter. If you left the key or if you keep on plugging it for a long time, then what will happen? Current will keep on flowing through the resistance and resistance gets heated. So if the resistance gets heated, its resistance will change. And then V by I, which is R, in first reading, the value of V by I is different. In second reading, the value of V by I is different. Whereas for every value of V and I, R should remain constant. So why it arises? Because of errors due to external causes. So external causes may be temperature changes. So due to change in temperature, the resistance of particular element will not be constant. The particular element will have a different resistance, and then V by R ratio will change. And that's why some condition under some constraint like pressure, temperature, strain, these should remain constant. Then only you can perform this experiment in a nice way, in a correct way. And the fifth one is errors due to external causes. Then list count error. List count error. So the first thing arises, what is list count? So list count is the minimum count of the apparatus. So your meter scale has list count, you know. What is the list count of meter scale? List count of 1 millimeter. So error may occur up to 1 millimeter. This is very much usual. And list count of your wristwatch is 1 second. So least measurement that can be done with the help of that instrument is 1 second. That is for wristwatch it is 1 second. So error of 1 second may occur usually. So that's why this is called list count error. In a screw gauge also list count term is involved. In vernier caliper, in microscope, there are several instruments where list count, like voltmeter, galvanometer, list count you have to find, and then you have to measure the reading. Now these are simple meaning of list count error. Error due to external causes, personal error, imperfection in experimental technique, and instrumental error. Simply the type of systematic error. These are the types of systematic error. Now we are moving towards the random error. Random. The second part is random error. So we are writing here random error. So random error are the errors which occur irregularly due to unpredictable variations in experimental condition. So random errors are the errors which occur randomly due to not randomly, irregularly due to unpredictable variation in experimental condition. Suppose you are doing the experiment of Boyle's law, P inversely proportional to V, when temperature remains constant. Now due to some reasons temperature changes, then your reading will not be correct. Then Boyle's law, if you want to verify the Boyle's law, then Boyle's law cannot be verified. Suppose you are doing the experiment of Ohm's law, where temperature pressure should remain constant, but because of some reason temperature pressure changes suddenly, because that control is not with us, atmospheric variation, pressure, temperature, and because of that resistance changes. So then every time you are not getting the same value of resistance. That's why random error is such type of error which are the errors which occur irregularly. Sometimes it occurs, sometimes it may not occur due to external due to variation in unpredictable variation in experimental condition. Experimental condition is not same. Almost same. Random errors means sometimes you will find that some error comes, and at the other time you may not find. So if you are doing the experiment today, you may find some error, but if the same experiment is repeated on tomorrow, then you may not find this error because of the experimental condition, or this is called random errors. Sometimes you have to place the things parallel to horizon. and because of some reason it is not placed parallel to horizon, it is somehow tilted. Then random error are the errors which occur irregularly due to unpredictable variation in experimental conditions. Sometimes experimental conditions changes, that is not predicted, but because of sudden change in atmospheric temperature, pressure, that condition is changed. So because of change, the error comes into picture, and that is called random. Nothing more. This is enough to know about this. And the last one is gross error. Gross error. Gross error. So these errors arise on account of sheer carelessness of the observer. So this error arises due to sheer carelessness of the observer. So while taking the reading of a meter scale, suppose you are going to measure the length something, and this is the final end. You are going to measure it from, so this is the final end. So if you are looking it from this position, this is your eye. So if you are looking perpendicular, observation is taken perpendicular, your eye should be perpendicular to this end. Then your reading will be correct. But if you are taking the reading by putting your eyes here, then you will observe a little bit earlier this point. Or if your eye is placed here, okay, then you may note this reading. So if you are looking it from this side, then a difference occurs from left and right. So then what is the correct way to take the reading or to take the observation? You should place your eye perpendicular to that point. Perpendicular to that point. This is nothing but parallax error. Parallax error. So your eye should be placed perpendicular to this position so that correct reading should be taken. This is called gross error. And in personal error, the person may have only one eye. Okay. Then gross error is due to the, suppose if you are putting your eyes in this position, then you will observe this line. And if you are putting your eyes in this position, then you will observe this line. Whereas correct position is this. So it will be less, yeah, casualness of the observer. And sometimes it happens that the observer, say in Ohm's law, current is going on through the resistance and resistance becomes heated and heated. And then finally, after 2-3 minutes, after 5 minutes, he is going to take the reading. Obviously, the parameter will change and resistance will change. So, why it occurs? Because of sheer carelessness. Sheer carelessness. So that fellow, that student is keeping him or herself in busy in gossiping. So gossiping means current is going on, and because of the flow of current through the resistance, it gets heated and the resistance changes. And the next time you are taking the reading, so reading will be different. So that becomes an error. Why this error arises? Because of your sheer carelessness. That is called gross error. So this is a type of error. Now the major part is you have to study how to error is getting propagated and what is absolute error, that is relative error. So now we are going to study absolute error. Okay, take the snapshot. I will rub the whole board. I will rub the whole board. Take it. Now moving towards from this portion, question is normally it doesn't come. Question comes from the portion which I am dealing just now. Now, the next part is absolute error. What do you mean by absolute error? Okay, written. So absolute error in the measurement of a physical quantity is the error is in the measurement of a physical quantity is the magnitude of the difference between true value and the individual measured value of the quantity and individual measured value of the quantity This will become more clear by starting one example. So let A1, A2, A3, A4, dot 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 An are the individual measured value of a physical quantity by someone. So let A1, A2, A3, dot 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 An, or you may write capital or small n. So let measured value of a physical quantity A1, A2, A3, An be the individual measured value of a quantity, physical quantity. Okay? So suppose you are going to measure the length of this pen. Okay. If it is not known to you that what is the actual length of this pen, and you have measured the length by using a scale, you have a scale also. So you are putting it. So first time you are putting, so what is the reading A1? Now again you are putting it second time. The reading is A2. Third time A3. This way you are taking n readings of the length of this pen. Then how will you come to know that what is the true value? What is the true length of the pen? If it is not well known to you in some other ways, then the best way is to take the arithmetic mean of all the individual value. Take the arithmetic mean. There may be some error in this measurement. There may be some error in this measurement. There may be some error in this measurement. But take the arithmetic mean. Add all these, divide it by the number of readings, you will get the arithmetic mean. And that will be the best value, that is the true value. And if someone has measured it before you take the readings, then that will be the true value. So, true value, how will you find? Mean value. So, mean absolute, mean of these, the arithmetic mean, I am talking about the arithmetic mean. The arithmetic mean of the quantity, measurement. The arithmetic mean of these values. So how will you find? Suppose this is A arithmetic mean represented by AM, M for arithmetic mean. Then AM is equal to nothing but A1 plus A2 plus A3 plus dot 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 plus AN divided by total number of readings. N readings. You have taken N readings. So divide it by N. So this is summation ai 1 by n I equals to 1 to n. Should I write like this? 1 by n summation ai I equals to 1 to n. Am is taken as true value of the quantity arithmetic mean. Am is taken as true value of the quantity, true value of the quantity, if the same is not known otherwise. If the same is not known otherwise, not known otherwise, then arithmetic mean gives you the true value. That is the best value. And then we are talking about absolute error in the individual measurement. So we are going to find absolute error in individual measurement. Okay, take the snapshot. I will rub this portion. Taken. So now, after defining it, absolute error in the individual measured value, in the individual measured value. So we are finding measured values of the quantity of the quantity. So the first is delta A1. So this is nothing but AM minus A1. So what is the mean value? Arithmetic mean, that is true value. True value minus individual measured value. This difference gives you delta A1. That is the absolute error in first measurement. This may be positive, this may be negative. This may be positive. So if the arithmetic mean comes to be 10 centimeter, and you, according to your observation, in first reading of the length of this pen comes to be 10.1 centimeter, then you have to subtract 10 minus 10.1. Or this may be 10, this may be 9.1, this may be 9.8, this may be 9.9. So absolute error in the individual measured value of the physical quantity is nothing but difference of arithmetic mean and the individual measured value. Individual measured value. Suppose you are measuring the length of this pen and the actual length is, I don't know, actual length may be 10 centimeter, but you have taken 9.9 centimeter. In second time you are taking 9.8 centimeter. In third time it may be 10.1 centimeter. It may be 10.2 centimeter. Then you are going to find the absolute error in each measurement. So what is the absolute error in first measurement? So that is mean, that is true value minus individual measured value. This gives you absolute error in first measurement. Similarly, what is absolute error in second measurement? Yeah, A mean minus A2. What is absolute error in third measurement? That is AM mean minus A3. This way, keep on going, proceeding in this way. Finally, now tell me what is del AN, nth measurement. So that is AM, AN. Yeah, right. So delta A1 may be positive, may be negative, depending upon. Suppose this is 10, this is 10.1. Then difference will be negative. Delta A2, this is 10, this may be 9.9. Then difference will be positive. So absolute error may be positive, negative. Okay. Now we are talking about the mean absolute error. Mean absolute error. Mean absolute error. Mean absolute. So then mean absolute error. Mean absolute error is nothing but take the mean of magnitude. So it is the arithmetic mean of magnitude of absolute error in all the measurements of the quantity. So it is the arithmetic mean. Arithmetic mean of the magnitude, arithmetic mean of magnitude of absolute error, absolute errors in all the measurements of the quantity. In all the measurements of the quantity. So then mean absolute error can be written as, now you can write the mean absolute error as delta A mean. You can write delta A M also, or to make it more clear I am writing mean, so that it will be easy for you to understand. Delta A mean is mod of delta A1. Take the mod, because this is positive, this may be positive negative, but you have to take the mod only, plus delta A2 plus delta A3 plus dot 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 finally delta N divided by N. So this you can write 1 by N summation delta AI mod I equals to 1 to N. I equals to 1 to N. Final result of measured value may be written as, you have written up to this point. Now can I write here? Okay. So I am putting 3 star 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 for your reference, continuation. So then the final result of measured value may be final result of the measured value is equal to A mean plus minus del A mean. You may write M or MEN also. These are same thing. A mean. You may write mean also. Arithmetic mean. A mean plus minus delta A mean. A mean plus minus delta A mean. Okay. Now we are talking about relative error. So it means your values comes in between. That is A mean plus delta A mean or A mean minus delta A mean. In between your value will lie. So plus minus, this part is error. Okay. So now take the snapshot. I will rub the board. Taken. Okay. Now all of you have written. Should I rub the board? Okay. So now the relative error. We are talking about a relative error. Relative error. So it is the ratio of mean absolute error to the mean value of quantity measured. So it is the ratio of mean absolute error to the mean value of quantity measured. Means relative error is equal to delta A mean divided by A mean, delta A mean by A mean. You may write A mean AM also. So delta A mean by A mean, this gives you relative error. And what is percentage error? Percentage error. So simply multiply it by 100, this will give you the percentage. So del A mean by A mean into 100. This will give you the result in percent. This much percent. That is delta A mean by A mean into 100%. Now before we go further, let me solve one problem, and I think this is the problem from your textbook. So you are going to measure the time period of a simple pendulum, and the time period comes to be, now I am not going to write the whole question, now I am dictating. So suppose time period of a simple pendulum, you have taken it several times, and suppose the time period comes to be T1 is equal to 2.63 second. Now second time you are taking, this comes to be 2.56 second. Third time it is coming 2.42 second, and T4 fourth observation 71 second, and the fifth observation is 2.80 second. So these are 5 observations. You have taken the time period. So how will you find the time period of simple pendulum? Just oscillate it. Suppose this is oscillating. So what is the time period? Time taken by the bob to complete one full oscillation. So this is half oscillation. Now it is full. Now start the stopwatch and then stop it here. See the time. What is the time taken to complete one oscillation? So that is called time period. And since it is very difficult to find time period in one oscillation, to count the time of one oscillation, that's why it is advised that you should take for 10 oscillation. What is the time for 10 oscillation? Then divide it by 10, you will get the time for one oscillation. So this way you can take the time of 10, 20, 50 oscillation and then divide it by the number of oscillation. This will give you the time for one oscillation. That is time period. So a student performed the experiment and finding the time period of simple pendulum in 5 experiment readings, T1, T2, T3, T4, T5. 5 times he has repeated the same phenomena and then recorded the reading. Then if I ask you, calculate the absolute error, relative error and percentage error. Now the question is, you have to calculate the absolute error, okay, first bit, second relative error, and then finally percentage error. Percentage error. So how will you find the absolute error? So what is the arithmetic mean of this time? So just take the arithmetic mean. So the mean period of oscillation of the pendulum, the mean period of oscillation, the mean period of oscillation. So how will you get the mean? The mean period of oscillation of the pendulum is equal to, that is T1 plus T2 plus T3 plus T4 plus T5 divided by 5. You just add all these. So should I write here 2.63 plus 2.56 plus 2.42 plus 2.71, just add all these 5 plus 2.80 divided by 5. You just add all this quantity and then divide it by 5. Finally you will get, I am writing directly, it comes to be 2.624 second. That is 2.624 second. Okay. So this is approximately written as 2.62 second because your each observation has three significant figure 2.63. So then it is 2.62. Take only 3 digits. So after decimal take 2 digits only. After decimal 2 digit, 2 digit, 2 digit. Okay. So 2.62. The reading is 2.62 second. This is mean reading, mean value, mean time period. Once you know the mean time period, now absolute error in each measurement can be found. So, okay, should I rub it or this I am calling TM, mean value, mean time period, mean time period. Take this screenshot, I will rub the upper part. Okay, taken. Now, I am rubbing this upper part. Okay. Now I am not doing the calculation part I am leaving for you. You can just see at your home what is the total and then divide it. The final result I am writing. Now the absolute error in the measurement are, the absolute error in the measurement are, the first reading is Tm minus T1, that is arithmetic mean minus individual measured value. So what is it? Tm 2.62 minus 2.63. That difference comes to be minus 0.01 second. Minus 0.01 second. Okay. What is Tm minus T2? So 2.62 and what is T2? 2.56. So just take the difference. It comes to be 0.06 second. 0.06 second. Now in third reading, Tm minus T3. So this is 2.62 minus T3. What is T3? 2.42. Now take the difference. It will be 0.20 second. 0.20 second. Now Tm minus T4. So 2.62 minus what is T3? 2. No? T4. T4 is 2.71. And the difference comes to be minus 0.09. Minus 0.09 second. And finally, Tm minus T5 is 2.62. And what is T5? 2.80. So that difference it comes to be minus 0.18, minus 0.18 second. Okay. Then you have to find mean absolute error. So how to find mean absolute error? That is mean absolute error is nothing but mod of this one. That is, you have to add, take the mod, all positive value. That negative value is converted into positive. So 0.01 plus 0.06 plus 0.20 plus 0.01 plus 0.18 divided by 5. So you have to take the mod of each difference. So this may be positive, negative, but take only, convert this into positive, take the positive only. And then add all the 5 divided by 5. So your answer will comes to be 0.11 second. 0.11 second. After adding and then dividing it by 5. 0.11 second. Then your observation will be T is equal to, what was the mean? Tm is 2.62. So 2.62 plus minus delta A mean. So this is delta T mean. Delta T mean. So delta T mean is 0.11. This much second is the final result. So the period of oscillation lies between, now if you add plus something and if you subtract this quantity, the period of oscillation comes to be in between. The period of oscillation comes in between. Now if you add 0.11, then what you get? 2.73 second, and if you subtract minus 0.11, then you will get 2.51 second. Now to find relative error, what to do? You have to just divide it. Relative error is this delta T mean divided by T mean. So that ratio is relative. Should I wrap this part? So relative error, the second part I am doing, this is first part. Now second part is relative error. So relative error is delta T mean by T mean. So what is delta T mean and what is T mean? 2.62. Now if you divide it, 0.041 plus minus, put a plus minus sign also, plus minus. So this after divide you will get plus minus 0.041, 0.041, and what is percentage? Multiplied by 100. So percentage error is equal to 0.041 into 100. So it's how much? Plus minus 4.1%. Plus minus 4.1%. Yeah? So by solving this example, you will be fully able to understand how to find absolute error, what is absolute error, what is mean absolute error, what is relative error, what is percentage error. Everything is clear from this simple example. Okay? Am I clear to you? Any problem? Clear? Clear? Crystal clear? Yeah, crystal transparent. So by solving a numerical, the theory portion will automatically be cleared. Automatically become crystal clear. So application part.